Welcome back, viewer, to your favorite program, Science Hub. With you here are Oscar Ojuku and Ian Ochako. Now we'll be discussing the second topic of physics, which is measurement 1. And I'd like my counterpart, Ian Ochako, to explain more.
In physics, we do measurement 1 as the second topic. Measurement 1, the scientists from all over the world in 1960 came up with the SI units that were to be used to measure specific units. These SI units stand for System International. There are 7 basic SI units. And Alvin, Oscar, what can you say about these 7 basic SI units? I'll start you off with length. Length being measured in meters, and the symbol is m. What can you say?
Now, we have the SI units, the basic quantities are 7. Now we also have thermodynamic temperature. The SI unit for thermodynamic temperature is Kelvin, and its symbol is K, capital K. Many people may sometimes confuse the symbol and the SI unit. The name is the SI unit, Kelvin, and this K is the symbol. Another SI unit is luminous intensity. Its SI unit is Kelvin, and its symbol is capital C and E. Now, the other quantity is mass. Now, the SI unit for mass is kilogram, and it is represented by the symbol capital K and G. I'd like my friend Ian Ochako to explain more about the other quantities.
More to it, we have also the amount of substance. We can also have the amount of substance. We can also have the amount of substance. Which the SI unit is mole, and the symbol is MOL. More to it, we have time. Time is measured in seconds. And the SI unit is small letter s. In order to you can first of all dwell on length. Length is the distance between 2 points in space. For example, from point A to point B, this distance in between here can be defined as length. We have examples of length. For example, we can have the width and the length. For example, in a rectangle, from this distance to this distance can be stated as the length. The length, or this one is the length. Other examples are the radius from this point to this point. Also the radius, which is a part of the length, and more to it,
Now, length, we also have width, as he has explained. We also have height. Now, this here is the height. The distance from here to here is the height. Now, we are going to look at measuring length. Now, measuring length, the main instrument used in measuring length is a meter rule, as you can see here. Now, the main instrument is a meter rule. Here, no chap, if I may ask, how is the meter rule calibrated?
It is calibrated in centimeters.
Yes, centimeters, or some may have meters. Now, using a meter, we can demonstrate the next procedure. This is the procedure of using a meter rule. Now, here, meter rule is calibrated in centimeters, not meters. Now, the first procedure is the meter rule should be in contact with the object. No one should measure or like this or like this. The meter rule should be in contact with the object. Now, the second procedure is the zero mark should align with the end of the object, meaning that the zero mark should be at the end, for example, of my physics textbook here. And the third procedure is the meter rule should observe the measurement, but the eye should be placed perpendicularly to the meter rule, meaning that you should not look at the measurement while slanting or like this or like this. The eye should be placed perpendicularly to the meter rule. If you ignore this procedure,
an error may occur.
And this error is known as yellow chapel. What is the name of this error?
First of all, there are two types of this error. First of all is the parallax error. And the zero error reading. The parallax error is caused when the eye is not placed perpendicularly above the object being measured. For example, if this is the object and this is the meter rule above here, and you place your eye here perpendicularly, this is the object and the meter rule is over there. Then you place your eye here. This is perpendicularly, but when somebody places his eye from this point, we will read something more or less of the actual reading, or rather from this side will record something that is either more or less. So in order to reduce this error, one must place the eye perpendicularly on the object in order to reduce this error. On the zero error reading, this can occur. For example, this meter rule, when it is calibrated and doesn't start from the point 0, you can have an error reading. This error reading can be reduced by either by noting down the problem, noting down the measurement from where you start from. For example, if this one started from 1, I'll note it down, then it ends at 21. I'll note them down, then subtract. to get the final measurement as 20. Remember, therefore, you can not only use the meter rule to measure the length, you can also use a tape measure. Tape measure. There are three different types of tape measures as a point to note, and Alvin can tell us Oscar can tell us what are the matters to consider when choosing either of these three tape measures.
Here, first, we see what are you measuring first. The meter rule can be used to measure small objects like a physics textbook here. The types of tape measures. We have the surveyor's tape measure. This is mainly used by surveyors when measuring the length of the land which they are either selling or want to develop. Here, Chapo, can you give us another?
We have the Taylor's tape measure. And also the Carpenter's tape measure.
Here, Chapo, let's get started on this. A Taylor's tape measure is used by tailors in making clothes and shoes and clothes, vests, such things. And a carpenter's tape measure is used to make furniture, mostly furniture. Measuring the length of wood to use. Now, here the Chapo. Can you take us to the next subject?
More to it, you can also, but note that this surveyor's tape measure is mainly used to measure for example, the distance of a javelin throw. For example, the javelin sent to this point can be used to measure this distance. More to that, we can go on to area, measurement of area. First of all, area is the distance, the extent of space occupied by matter. For example, if this is the object, it has occupied this area. First of all, how do you measure area? Area can, for example, if the area of regular objects, use the mathematical formulas such as, for example, rectangle. We use the mathematical formula of length times, and the circle, use the mathematical formula of pi r square. You can therefore move on to the area of irregular objects. Oscar, what can you say about measuring the length of irregular objects?
Let's explore on this. Area is a derived quantity, meaning it is either derived quantities are either got from the multiplication or division of basic quantities which we named earlier. Now we are going to do the irregular area of irregularly shaped object or yes. Now, in order to measure, you may have a figure such as this one.
Measuring cylinder. You should first of all pour a reasonable amount of liquid or water. Note it down as the first volume. Then tie the irregular object such as, for example, the stone, and gently immerse it into the liquid. Therefore, the new volume of water will slightly be above this point. Then you note the new volume of water, which is volume 2. In order to get now the volume of the irregular object, you should therefore do the math volume 2 minus volume 1 to remain with the volume of the irregular objects. In order, you can also use the displacement method, which comprises of the use of a eureka can. You should first of all fill the eureka can with water up to the spout. The water should overflow until through the spout, and when it has already overflowed, place a measuring cylinder, an empty measuring cylinder. Then therefore tie the irregular object with a string and immerse it into the eureka can. You will notice that some of the liquid will be poured inside here to make the measuring cylinder partially filled with water. The volume that will be displaced into the measuring cylinder will be equal to the volume of the irregular shape that was immersed into the eureka can. We can now therefore move on to the volume of liquids. Volume of liquids. Volume of liquids can be based mainly because since liquids don't have a definite shape, we will use regularly shaped objects to measure their volume. For example, if it's placed in a cuboid again, and the volume is placed to this point, you get the volume by length times width times height, but not the full height, the height up to this point. So we can therefore, Oscar can take us through the next subtopic.
I'll just expound on what you said about the measuring irregular objects. We also have other instruments used in measuring volume, which are the burette, pipette, volumetric flask, and the syringe.
So in order to measure the density of the volume of irregular objects, we say that you must first fill the eureka can with water till it runs out the spout. After this, place an empty measuring cylinder under it, then immerse the irregular solid inside the eureka can. Once it has ceased coming out through the spout, you can form a conclusion that the water that is displaced into the measuring cylinder can be measured as the volume of the irregular object. We can therefore move on to density. Density. Oscar, what can you say about density? Density can be defined as mass per unit volume. Its SI unit is kilograms per cubic meters. It can also be measured in grams per cubic centimeters. Now we can move to one of the equipments used in the defining of density is a density bottle. You can first of all find the density of solids. Density of solids can be derived from this definition of mass per unit volume. Even in liquids, you can use a density bottle. This is the apparatus for measuring that is used to find the density of a liquid. So you can find the mass of the bottle alone. You place the density bottle on a weighing balance, then you note it down. Then therefore find the mass of the bottle plus water. After filling this with water, you place it again on the weighing balance and note it down. Then you derive the mass of the water. Water alone will be mass of bottle plus water minus mass of the bottle. Mass of water alone, then you note it down. Then the volume can be found by the volume. Point to note is that the volume of the density bottle is usually indicated on the side. As you can see, this one is 25 milliliters. So you note it down. Then you use the same formula of density, which is mass over volume. Oscar can therefore take us through the measurement of time.
Time. Time is calibrated in seconds. Seconds is mainly the SI unit of time. And we also have other units of time, which are hours and minutes, which are both derived quantities. And time is not a vector quantity, it's a scalar quantity, because it don't have magnitude but no distance. Now, thank you for watching Feeling TV, where you watch and learn.